Thank you very much. It's a pleasure to be with you. I'm lucky also. I work at the Pacific Institute. We're a research organization in Oakland, and we're celebrating our 25th anniversary this year. We're excited about that. And we've been working on the impacts of climate change on California water resources for those entire 25 years. In the last few years, we've done a handful of studies looking at the impacts of sea level rise and coastal changes, how those are likely to affect our state. So when you're talking about the southwestern United States, California is really it in terms of coastal areas. In terms of our oceans and coasts, what are they going to look like in a warmer world, and why does it matter? A lot of the things that civilize life as we know it are huddled close to the coast. So I'm from the Bay Area, so this is naturally a picture of downtown San Francisco, and you can see we've got a lot of things that we really care about. And the Bay Area, it's been said, if you're standing on flat land in the Bay Area, you're probably standing on fill. And this is land that was actually created after the massive influx of immigrants after the gold rush. And when you fill land, you don't fill it any higher than you have to. So a lot of flood risk concentrated in the Bay Area, but not just in the Bay Area. If you look at the beaches in Southern California, you see a lot of development that's clustered really close to the shoreline. And our beaches, I think, not just an important part of our identity as Californians, but also tremendous economic driver in terms of recreation and tourism for the state. I'm not going to show a lot of graphs, but this is fairly typical. This is measured, observed tide levels from San Francisco, and I could have showed a tide gauge from anywhere on the western coast of the United States, and we'd see a similar trend. I chose this one because it's the longest continually operating tide gauge in North America. So we've got data for over 150 years, which is wonderful. And you can see a really clear trend in that sea levels observed have steadily increased for just about as long as we've been measuring them. And this rate of 2 millimeters per year, it doesn't sound like a lot, so it makes sea level rise sound like this sort of gradual creeping menace, and we should be able to accommodate and move out of the way and deal with this threat pretty easily. I would like to assert that it's not a gradual creeping menace, but rather something that is going to evidence itself during extreme events, during floods. And floods in the future are going to be more intense and more frequent and posing tremendous risks to lives and property and our infrastructure in the state. We can also expect to see increased coastal erosion. I'll talk a little bit about some of the steps that we're likely to take or should take to help defend our coasts and against the impacts of flooding and what some of the consequences of that might be. So rather than thinking of sea level rise as something that is going to be far off into the future, it's something we can see right here and right now. This is in San Francisco. This is Pier 1/2. And this has been called by some the first casualty of sea level rise. It's already been condemned, and part of it was age and structural deterioration, but also a big part of this was waves that were hitting it more forcefully and more frequently on the bottom side, causing it to break down over time. We've also seen transportation-related impacts along our bluffs and dunes and cliffs. As you have waves that are hitting higher on these bluff faces, they're carrying off material, causing increased erosion. Caltrans is really out ahead of this issue. They're doing a lot of research looking at where they're going to have to make investments, and they're looking at spending millions in the next few decades to shore up some existing infrastructure, move some of it where necessary. So this is a section of Route 1 that's already been shored up, obviously. Another graph, this is a time series plot that was in the IPCC, the Intergovernmental Panel on Climate Change's third assessment report, which was published over 15 years ago now, but I think it's a really important chart. So I just want to spend a couple minutes looking at some of these different variables out into the future and how they're likely to sort of play out. And the bottom line, this brown line, is our CO2 emissions. So we expect it to peak at some point, hopefully in the near future, potentially sometime in the next 0 to 100 years, either because we've come to some sort of agreement about limiting greenhouse gas emissions, like we've done here in California, if the rest of the world gets on board, or simply because we've run out of fossil fuels to continue burning. Unfortunately, there's a long time lag effect. CO2 concentrations are expected to continue to rise for 100 to 300 years. So even if we parked all our cars, turned off all our power plants today, there's a certain amount of climate change that's going to happen and that we're sort of locked into. Temperatures will continue to rise for longer after that, and then sea levels will continue to rise for a couple of different reasons. One, warmer water just takes up more space. It occupies more volume, thermal expansion. The other reason is melting of ice sheets. We've heard about Greenland and Antarctica way out into the future. If those were to melt completely, if we lost the entire Antarctic ice sheet, we're looking at 30 meters, so nearly 100 feet of sea level rise. That's all of our coastal cities, London, Tokyo, San Francisco, really just ceasing to exist. That, I think, is what we would call an unimaginable. So I think when we talk about climate change, a lot of people say we need to avoid the unmanageable. So we need to avoid those really high scenarios, and we need to manage the unavoidable, because we know some of it's going to take place, and so we need to start talking more and more about climate adaptation, how we're going to deal with some of these changes that we know are going to take place. So how much sea level rise can we expect along the coast of California? We're fortunate in that we've got some tremendous scientists, Scripps Institution, the UC system, and a bunch of others who've looked in detail at some of these issues and run a lot of these climate models and done the assessments. So this graph shows, talking about uncertainty, the cone of possible outputs. It depends on which scenario, how much greenhouse gas emissions there are, which model you believe. So AR4 is the fourth assessment report of the IPCC, and these were the older estimates which have been largely superseded. The National Research Council published last year in this report looking at levels anywhere between 1 and 2 meters. So we're talking 3 to 6 feet is really what some of the experts are expecting in terms of what's likely by the end of the century. And so the levels that California has adopted for planning purposes, and Governor Schwarzenegger, I have to say, that, the executive order in 2008 directing, among other things, all state agencies to take into account sea level rise in all their planning, I think was tremendously forward-thinking, really an example to the rest of the nation. So we've adopted levels 16 inches by mid-century 2050, and then 55 inches by the end of the century. And so our organization and others have done a lot of mapping work. And so 16-inch sea level rise, this is San Francisco International Airport. By mid-century, looking at areas that are vulnerable to flooding, it's actually not much worse by the end of the century. This is all built on fill, so this is all new land that was created not that long ago. So fine, you think, well, I'm flying to the Bay Area, I'll fly into Oakland. Not so much. Again, and these are areas that are protected behind low levees, but unless these were strengthened or raised, they would be potentially inundated by mid-century. Silicon Valley, again, an area with a lot of low-lying land, formerly agricultural, a lot of groundwater pumping, which has caused the land to subside, and much of it is actually below sea level now. And this is the area, if you look at the headquarters of Google and Intel and Oracle, Facebook, all these tech giants that are really driving our economy in the Bay Area are located in these areas that are vulnerable. So what do some of these levees look like? This would be fairly typical of some sort of earthen materials, unconsolidated. They're faced with rocks, which engineers, we call it riprap to be a little more technical. So these are not the kind of highly engineered levee structures that we know can't fail. Actually, I remember talking to a community activist from New Orleans, and she said to me, we believe there are two kinds of levees, those that have failed and those that are going to fail. And based on their experience. And a lot of folks have said the next Katrina could take place in California, the next Sandy. I don't think that's rhetoric that's really overblown. When you look at what is potentially in harm's way, this is a slide from our 2009 report on the impacts of sea level rise on the state, where we looked at how many people would be in the 100-year floodplain in the future with sea level rise. And the answer was about 500,000 people. And one of the surprising results to me, and the size of these bubbles represent by county the number of people. So you can see Orange County is a place with quite a large population, and then a lot in the Bay Area, Alameda County, San Mateo County, San Francisco. And maybe one of the surprising results to me was that it's not just wealthy folks in their multi-million-dollar seaside homes. It's a broad cross-section of Californians. As you know, we're one of the most diverse places in the country, if not the world. And we had significant populations of low income, communities of color. And so when you start thinking about some of the more vulnerable populations, they're among this group that would be affected. So how do I think we ought to respond to this challenge? What are we likely to do? I mean, one of the things we need is climate-proof design or no regrets design. And I think California is extremely well poised in this regard because we've got some of the best architects and engineers and planners in the world. This is an example of, it's the Confederation Bridge. It's up in Canada. It connects Prince Edward Island to the mainland. It was designed with a design lifetime of 100 years, and they designed it to withstand up to 1 meter of sea level rise, which now we're unfortunately learning may not have even been enough. Better land use planning. So in the Bay Area, there's really no one agency. On the coast, we've got the Coastal Commission. In the Bay Area, the Bay Conservation and Development Commission. There's not one agency that can say no to if you're going to build something that's in a floodplain in the future. So how do you deal with some of these? I mean, the most common sense way to keep people out of harm's way is to prevent people from building there in the first place. And I think in a way, the flood insurance profession and the engineer, my profession, we've done a bit of a disservice by identifying these 100-year floodplains. It sounds like something that's extremely rare, whereas in reality, a lot of people don't realize if you buy a house that's in the 100-year floodplain, that has a 1% chance of occurring in any given year, over your 30-year mortgage, you've got a 24% chance of being flooded one or more times. And if you're looking into maybe in the next 5 years, that's going to be not a 1% chance, but a 2% chance. So the 100-year flood becomes the 20-year flood. So you've got folks that already were exposed to risk, being exposed to greater risk, folks who thought they weren't exposed to risk because these floodplains are going to be moving upland and inland, newly exposed to risk. We're likely to harden our coasts and build defenses, seawalls and levees. Unfortunately, these do come with side effects. The more often than not, what you see when you've built a seawall is you end up with water and a wall, and you lose the beach that was downstream, on the seaward side of that, which has tremendous recreational value and ecological value. So all of the values that go along with that, we need to really look at what we value about the coast and how we can preserve some of those values. This is an example near Monterey, Fort Ord, the old Army base. It was Stillwell Hall, was the officers' club, and maybe a misguided effort to try to prevent that from the coast, which was being eroded, from crumbling into the sea. They put a bunch of rocks, and you can see they've lost the entire beach there. The good news is that this was a reversible process. When they removed some of that protection, some of the natural processes were restored, and they were able to restore the beach. So that's a success story for the beach, not a success story for this particular building, which was historic. We need to protect and preserve our coastal wetlands. In the state of California, we've lost historically 96% of our wetlands by dredging, filling, converting to agricultural land. So the marginal value of every acre of wetland that we can preserve or protect or restore is extremely high from a habitat value, but also from a very for selfish reasons, they have a tremendous value for flood protection. Wetlands absorb floodwaters, they soak up wave energy, and so what I've heard Will Travis, who was the director of the Bay Conservation and Development Commission, say is that the wider your wetland at the front, the shorter your levee needs to be at the back. And so this is sort of green infrastructure versus gray infrastructure, a way to sort of engineer with nature to mitigate flooding. I'll wrap it at that. There's a lot more in some of our publications, which you can find on our website at packinst.org. And there's also the Google map, and you can zoom in. If you live near the coast, you can zoom into your house and see how you're likely to be affected. Thank you very much.